We're going to look at the reaction of esters with Grignard reagents to create tertiary alcohols. When you do this type of chemistry, again, you would need to have an ester. And the conditions that you would observe are, first off, you need to have a Grignard reagent, and I'm not getting very creative here. This is usually at least 2 equivalents or excess. And you do all that first, and then eventually you will add an acid source. But you do not do this right off the bat. That would be a real problem. That needs to come after the fact. So what happens here? Well, first off, you have a Grignard reagent, and I hope you remember that Grignard reagents are extremely reactive. They're very strong bases. If you do not have an acidic proton, you're going to act as a base, or sorry, as a nucleophile if you can't act as a base. And I like to draw mine as ion pairs. It's a little easier to see what's going on. But your carbanion will act as a nucleophile and add to the carbonyl carbon. Can't have 5 bonds, so you break the pi bond to the oxygen to make a tetrahedral intermediate. And this is a negatively charged tetrahedral intermediate. Okay, this is where you are for a moment. Now, you are in a negatively charged solution, so you want to go from a stronger base to a weaker base. You started out with the Grignard reagent. You had a deprotonated alkane or a deprotonated alkene, depending on what you added. They are very, very strong bases, so you basically want to kick out a weaker base than what you started with. And as you look at this negatively charged tetrahedral intermediate, you want to reform the pi bond between the carbon and the oxygen, and that means you've got to kick out a group. There is one group that will create a much weaker leaving group, and that is the OCH3 group. That will still be basic, it will still be a strong base, but it's a much weaker base than what you started with. So this would be favorable acid-base chemistry. That's a good leaving group in this particular case. And this is going to result in a ketone. You will have some OCH3 minus. Those are your spectators. That's the end of the first step, but if you have excess Grignard reagent present, which you are going to have in a reaction like this, you've got more Grignard reagent available to do chemistry. And you have another carbonyl carbon, so this will act as a nucleophile toward the carbonyl carbon, and you will again open up the pi bond, creating again another tetrahedral intermediate. This is now alkoxide, though. It is the conjugate base of an alcohol. This time you cannot reform the pi bond, because if you did so, you'd kick out what you started with. You'd kick out a really strong base. So it doesn't have anywhere to go. It's going to stay right here. This is when you add the acid, and only now. So the acid's purpose would be to protonate the OCH3 minus up here at the top, and it's also going to protonate this alcohol that we have just made, this conjugate base of an alcohol. So the oxygen will come in and remove a proton and give electrons back. So that at the end of the day, we make a tertiary alcohol. So you're going to add 2 of the same group to what was the carbonyl carbon. And this is what we end up with at the end.